Introduction to Matlab for Engineering Students. David Hauschk, Northwestern University. Version 1.2, August 2005. Contents: 1 Tutorial Lessons 1.1 1.1 Introduction 1.2 Basic Features 2 1.3 A Minimum Matlab Session 2 1.3.1 Starting Matlab 2 1.3.2 Using Matlab as a Calculator 4 1.3.3 Quitting Matlab 5 1.4 Getting Started 5 1.4.1 Creating Matlab Variables 5 1.4.2 Overriding Variable 6 1.4.3 Error Messages 6 1.4.4 Making Corrections 6 1.4.5 Controlling the hierarchy of operations or precedence 6 1.4.6 Controlling the appearance of floating point number 8 1.4.7 Managing the workspace 8 1.4.8 Keeping track of your work session 9 1.4.9 Entering multiple statements per line 9 January 4th 10 Miscellaneous commands 10 January 4th 11 Getting help 10 1.5 Exercises 11 2 Tutorial Lessons 2.12 2.1 Mathematical Functions 12 2.1.1 Examples 13 by 2.2 Basic Plotting 14 2.2.1 Overview 14 2.2.2 Creating Simple Plots 14 2.2.3 Adding Titles, Axis Labels, and Annotations 15 2.2.4 Multiple datasets in one plot 16 2.2.5 Specifying line styles and colors 17 2.3 Exercises 18 2.4 Introduction 19 2.5 Matrix Generation 19 2.5.1 Entering a vector 19 2.5.2 Entering a matrix 20 2.5.3 Matrix Indexing 21 2.5.4 Operator 22 2.5.5 Linear Spacing 22 2.5.6 Operator in a matrix 22 2.5.7 Creating a submatrix 23 2.5.8 Deleting row or column 25 2.5.9 Dimension 25 February 5th 10 Continuation 26 February 5th 11 Transposing a matrix 26 February 5th 12 Concatenating matrices 26 February 5th 13 Matrix Generators 27 February 5th 14 Special Matrices 28 2.6 Exercises 29 3 Array Operations and Linear Equations 30 3.1 Array Operations 30 3.1.1 Matrix Arithmetic Operations 30 3.1.2 Array Arithmetic Operations 30 3.2 Solving Linear Equations 32 3.2.1 Matrix Inverse 33 3.2.2 Matrix Functions 34 3.3 Exercises 34 For Introduction to Programming in Matlab 35 4.1 Introduction 35 4.2 Meter File Scripts 35 4.2.1 Examples 36 4.2.2 Script Side Effects 37 4.3 Meters File Functions 38 4.3.1 Anatomy of a M-file function 38 4.3.2 Input and Output Arguments 40 4.4 Input to a script file 40 4.5 Output Commands 41 4.6 Exercises 42 5 Control Flow and Operators 43 5.1 Introduction 43 5.2 Control Flow 43 5.2.1 The if ... structure 43 5.2.2 Relational and Logical Operators 45 5.2.3 The for ... loop 45 5.2.4 The while ... loop 46. 5.2.5 Other flow structures. 46. 5.2.6 Operator precedence. 47. 5.3 Saving output to a file. 47. 5.4 Exercises. 48. 6 Debugging AMP files. 49. 6.1 Introduction. 49. 6.2 Debugging process. 49. 6.2.1 Preparing for debugging. 50. 6.2.2 Setting breakpoints. 50. III 6.2.3 Running with breakpoints. 50. 6.2.4 Examining values. 51. 6.2.5 Correcting and ending debugging. 51. 6.2.6 Ending debugging. 51. 6.2.7 Correcting an AMP file. 51. A summary of commands. 53. B. Release notes for Release 14 with Service Pack 258. B.1 Summary of changes. 58. B.2 Other changes. 60. B.3 Further details. 60. C. Main characteristics of Matlab. 62. C.1 History. 62. C.2 Strengths. 62. C.3 Weaknesses. 63. C.4 Competition. 63. ID List of tables. 1.1 Basic arithmetic operators. 5. 1.2 Hierarchy of arithmetic operations. 7. 2.1 Elementary functions. 12. 2.2 Predefined constant values. 13. 2.3 Attributes for plot. 18. 2.4 Elementary matrices. 27. 2.5 Special matrices. 28. 3.1 Array operators. 31. 3.2 Summary of matrix and array operations. 32. 3.3 Matrix functions. 34. 4.1 Anatomy of a AMP file function. 38. 4.2 Difference between scripts and functions. 39. 4.3 Example of input and output arguments. 40. 4.4 Dispensary and fprintf commands. 41. 5.1 Relational and logical operators. 45. 5.2 Operator precedence. 47. 8.1 Arithmetic operators and special characters. 53. 8.2 Array operators. 54. 8.3 Relational and logical operators. 54. 8.4 Managing workspace and file commands. 55. 8.5 Predefined variables and map constants. 55. V8.6 Elementary matrices and arrays. 56. 8.7 Arrays and matrices. Basic information. 56. 8.8 Arrays and matrices. Operations and manipulation. 56. 8.9 Arrays and matrices. Matrix analysis and linear equations. 57. VI list of figures. 1.1 The graphical interface to the Matlab workspace. 3. 2.1 Plot for the vectors x and y. 15. 2.2 Plot of the sine function. 16. 2.3 Typical example of multiple plots. 17. VII Preface. Introduction to MATLAB for engineering students is a document for an introductory course in MATLAB. Degrees are 1 and technical computing. It is used for freshman classes at Northwestern University. This document is not a comprehensive introduction or a reference manual. Instead, it focuses on the specific features of MATLAB that are useful for engineering classes. The lab sessions are used with one main goal, to allow students to become familiar with computer software, e.g., MATLAB, to solve application problems. We assume that the students have no prior experience with MATLAB. The availability of technical computing environments such as MATLAB is now reshaping a role and applications of computer laboratory projects to involve students in more intense problem-solving experience. This availability also provides an opportunity to easily conduct numerical experiments and to tackle realistic and more complicated problems. Originally, the manual is divided into computer laboratory sessions labs. The lab document is designed to be used by the students while working at the computer. The emphasis here is learning by doing. This quiz-like session is supposed to be fully completed in 50 minutes in class. The 7 lab sessions include not only the basic concepts of Matlab, but also an introduction to scientific computing, in which they will be useful for the upcoming engineering courses. In addition, engineering students will see Matlab in their other courses. The end of this document contains 2 useful sections, a glossary which contains the brief summary of the commands and built-in functions, as well as a collection of release notes. The release notes, which include several new features of the Release 14 with Service Pack 2, well known as R14 SP2, can also be found in Appendix. All of the Matlab commands have been tested to take advantage with new features of the current version of Matlab, available here at Northwestern R14 SP2. Although most of the examples and exercises still work with previous releases as well. This manual reflects the ongoing effort of the McCormick School of Engineering and Applied Science, leading by Dean Stephen Carr, to institute a significant technical computing. In the engineering first degrees are 2 courses taught at Northwestern University. Finally, the students' Engineering Analysis EA section deserve my special gratitude. They were very active participants in class. David Hausch, Evanston, Illinois, August 2005. 1 Matlab degrees are is a registered trademark of MathWorks, Incorporated. 2 Engineering first degrees are is a registered trademark of McCormick School of Engineering and Applied Science, Northwestern University. VII acknowledgements. I would like to thank Dean Stephen Carr for his constant support. I am grateful to a number of people who offered helpful advice and comments. I want to thank the EA1 instructors. Fall Quarter 2004, in particular Randy Freeman, Jorge Nosardel, and Talent Flood for their helpful reviews on some specific parts of the document. I also want to thank Malcolm McIver, EA3 Honors Instructor Spring 2005, for helping me to better understand the animation of system dynamics using Matlab. I am particularly indebted to the many students, 340 or so, who have used these materials, and have communicated their comments and suggestions. Finally, I want to thank IE personnel for helping setting up the classes and other computer-related work: Rebecca Swivers, Jesse Beckert, Rick Mazek, Alan Wolf, Ken Kalin, Mike Chase, and Daniel Lee. About the author. David Hausch has more than 25 years experience in the modeling and simulation of structures and solid continued, including 14 years in industry. In industry, he has been working as R&D engineer in the fields of nuclear engineering, oil rig platform offshore design, oil reservoir engineering, and steel industry. All of these include working in different international environments: Germany, France, Norway, and United Arab Emirates. Among other things, he has a combined background experience, scientific computing and engineering expertise. He earned his academic degrees from Europe and the United States. Here at Northwestern University, he is working under the supervision of Professor Brian Moran, a world-renowned expert in fracture mechanics, to investigate the integrity assessment of the aging highway bridges under severe operating conditions and corrosion. IX Chapter 1. Tutorial Lessons 1. 1.1 Introduction. The tutorials are independent of the rest of the document. The primarily objective is to help you learn quickly the first steps. The emphasis here is learning by doing. Therefore, the best way to learn is by trying it yourself. Working through the examples will give you a feel for the way that Matlab operates. In this introduction, we will describe how Matlab handles simple numerical expressions and mathematical formulas. The name Matlab stands for Matrix Laboratory. Matlab was written originally to provide easy access to matrix software developed by the LINPACK Linear System Package and EISPACK Eigen System Package projects. Matlab 1 is a high-performance language for technical computing. It integrates computation, visualization, and programming environment. Furthermore, Matlab is a modern programming language environment. It has sophisticated data structures, contains built-in editing and debugging tools, and supports object-oriented programming. These factors make Matlab an excellent tool for teaching and research. Matlab has many advantages compared to conventional computer languages, e.g. C, Fortran for solving technical problems. Matlab is an interactive system whose basic data element is an array that does not require dimensioning. The software package has been commercially available since 1984 and is now considered as a standard tool at most universities and industries worldwide. It has powerful built-in routines that enable a very wide variety of computations. It also has easy-to-use graphics commands that make the visualization of results immediately available. Specific applications are collected in packages referred to as toolbox. There are toolboxes for signal processing, symbolic computation, control theory, simulation, optimization, and several other fields of applied science and engineering. In addition to the Matlab documentation, which is mostly available online, we would 1. Recommend the following books, 2, 3, 4, 5, 6, 7, 8, and 9. They are excellent in their specific applications. 1. Basic features. As we mentioned earlier, the following tutorial lessons are designed to get you started quickly in Matlab. The lessons are intended to make you familiar with the basics of Matlab. We urge you to complete the exercises given at the end of each lesson. 1.3 A minimum Matlab session. The goal of this minimum session, also called starting and exiting sessions, is to learn the first steps. How to log on, invoke Matlab, do a few simple calculations, how to quit Matlab. 1.3.1 Starting Matlab. After logging into your account, you can enter Matlab by double-clicking on the Matlab shortcut icon. Matlab 7.0.4 on your Windows desktop. When you start Matlab, a special window called the Matlab desktop appears. The desktop is a window that contains other windows. The major tools within are accessible from the desktop are the command window, the command history, the workspace, the current directory, the help browser, the start button. To Figure 1.1, the graphical interface to the Matlab workspace. 3. When Matlab is started for the first time, the screen looks like the one that's shown in the Figure 1.1. This illustration also shows the default configuration of the Matlab desktop. You can customize the arrangement of tools and documents to suit your needs. Now, we are interested in doing some simple calculations. We will assume that you have sufficient understanding of your computer under which Matlab is being run. You are now faced with the Matlab desktop on your computer, which contains the prompt greater than in the command window. Usually, there are two types of prompt: greater than for full version, edu greater than for educational version. Note: to simplify the notation, we will use this prompt greater than as a standard prompt sign, though our Matlab version is for educational purpose. 1.3.2 Using Matlab as a calculator. As an example of a simple interactive calculation, just type the expression you want to evaluate. Let's start at the very beginning. For example, let's suppose you want to calculate the expression 1 plus 2 3. You type it at the prompt command greater than as follows: greater than 1 plus 2 asterisk 3. A and s equals 7. You will have noticed that if you do not specify an output variable, Matlab uses a default variable a and s, short for answer, to store the results of the current calculation. Note that the variable a and s is created or overwritten if it is already existed. To avoid this, you may assign a value to a variable or output argument name. For example, greater than x equals 1 plus 2 asterisk 3, x equals 7, will result in x being given the value 1 plus 2 3 equals 7. This variable name can always be used to refer to the results of the previous computations. Therefore, computing for x will result in greater than for asterisk x. A and s equals 28.0000. Before we conclude this minimum session, Table 1.1 gives the partial list of arithmetic operators. For Table 1.1, basic arithmetic operators. Simple operation example: plus addition 2 plus 3, subtraction 2, 3, asterisk multiplication to asterisk 3 slash division to thirds. 1.3.3 Quitting Matlab. To end your Matlab session, type quit in the command window, or select File. Exit Matlab in the desktop main menu. 1.4 Getting started. After learning the minimum Matlab session, we will now learn to use some additional operations. 1.4.1 Creating Matlab variables. Matlab variables are created with an assignment statement. The syntax of variable assignment is variable name equals a value or an expression. For example, greater than x equals expression, where expression is a combination of numerical values, mathematical operators, variables, and function calls. In other words, expression can involve manual entry, built-in functions, user-defined functions. 5.1.4.2 Overriding variable. Once a variable has been created, it can be reassigned. In addition, if you do not wish to see the intermediate results, you can suppress a numerical output by putting the semicolon at the end of the line. Then the sequence of commands looks like this. Greater than t equals 5. Greater than t equals t plus 1. T equals 6. 1.4.3 Error messages. If we enter an expression incorrectly, Matlab will return an error message. For example, in the following, we left out a multiplication sign, asterisk, in the following expression. Greater than x equals 10. Greater than 5x. 5x. Vertical line. Error, unexpected Matlab expression. 1.4.4 Making corrections. To make corrections, we can, of course, retype the expressions. But if the expression is lengthy, we make more mistakes by typing a second time. The previously typed command can be recalled with the up arrow key. When the command is displayed at the command prompt, it can be modified if needed and executed. 1.4.5 Controlling the hierarchy of operations or precedence. Let's consider the previous arithmetic operation, but now we will include parentheses. For example, 1 plus 2 3 will become 1 plus 2 3. Greater than 1 plus 2 asterisk 3. They and s equals 9. And, from previous example, 6 greater than 1 plus 2 asterisk 3. They and s equals 7. By adding parentheses, these two expressions give different results, 9 and 7. The order in which Matlab performs arithmetic operations is exactly that taught in high school algebra courses. Exponentiations are done first, followed by multiplications and divisions, and finally by additions and subtractions. However, the standard order of precedence of arithmetic operations can be changed by inserting parentheses. For example, the result of 1 plus 2 3 is quite different than a similar expression with parentheses 1 plus 2 3. The results are 7 and 9 respectively. Parentheses can always be used to overrule priority, and their use is recommended in some complex expressions to avoid ambiguity. Therefore, to make the evaluation of expressions unambiguous, Matlab has established a series of rules. The order in which the arithmetic operations are evaluated is given in Table 1.2. Matlab arithmetic operators obey the same precedence rules as those in Table 1.2, Hierarchy of arithmetic operations. Precedence mathematical operations. First, the contents of all parentheses are evaluated first, starting from the innermost parentheses and working outward. Second, all exponentials are evaluated, working from left to right. Third, all multiplications and divisions are evaluated, working from left to right. Fourth, all additions and subtractions are evaluated, starting from left to right. Most computer programs, for operators of equal precedence, evaluation is from left to right. Now, consider another example. 1, 2 plus 32, plus 4, 5, 6, 7. In Matlab, it becomes greater than 1 slash 2 plus 3 circumflex accent 2 plus 4 slash 5 asterisk 6 slash 7. They and s equals 0.7766. Or, if parentheses are missing, greater than 1 slash 2 plus 3 circumflex accent 2 plus 4 slash 5 asterisk 6 slash 7. A and S equals 10.1857. 7. So here what we get, two different results. Therefore, we want to emphasize the importance of precedence rule in order to avoid ambiguity. 1.4.6 Controlling the appearance of floating point number. Matlab by default displays only for decimals in the result of the calculations. For example, negative 163.6667, as shown in above examples. However, Matlab does numerical calculations in double precision, which is 15 digits. The command format controls how the results of computations are displayed. Here are some examples of the different formats together with the resulting outputs. Greater than format short. Greater than x equals 163.6667. If we want to see all 15 digits, we use the command format long. Greater than format long. Greater than x equals 1.636,666,666,666,667 e plus 002. To return to the standard format, center format short, or simply format. There are several other formats. For more details, see the Matlab documentation or type help format. Note, up to now, we have let Matlab repeat everything that we enter at the prompt greater than. Sometimes this is not quite useful, in particular when the output is pages in length. To prevent Matlab from echoing what we type, simply enter the semicolon at the end of the command. For example, greater than x equals 163.6667, and then ask about the value of x by typing greater than x. X equals negative 163.6667. 1.4.7 Managing the workspace. The contents of the workspace persist between the executions of separate commands. Therefore, it is possible for the results of one problem to have an effect on the next one. To avoid this possibility, it is a good idea to issue a clear command at the start of each new independent calculation. 8 Greater than clear. The command clear or clear all removes all variables from the workspace. This frees up system memory. In order to display a list of the variables currently in the memory, type greater than 2. While whose will give more details which include size, space allocation, and class of the variables. 1.4.8 Keeping track of your work session. It is possible to keep track of everything done during a Matlab session with the diary command. Greater than diary. Or give a name to a created file. Greater than diary file name, where file name could be any arbitrary name you choose. The function diary is useful if you want to save a complete Matlab session. They save all input and output as they appear in the Matlab window. When you want to stop the recording, enter diary off. If you want to start recording again, enter diary on. The file that is created is a simple text file. It can be opened by an editor or a word processing program and edited to remove extraneous material, or to add your comments. You can use the function type to view the diary file, or you can edit in a text editor or print. This command is useful, for example in the process of preparing a homework or lab submission. 1.4.9 Entering multiple statements per line. It is possible to enter multiple statements per line. Use commas or semicolons to enter more than one statement at once. Commas allow multiple statements per line without suppressing output. Greater than A equals 7, B equals cos A, C equals cos A, B equals 0.6570, C equals 548.3170. 9 January 4, 10 Miscellaneous commands. Here are a few additional useful commands. To clear the command window, type CLZ. To abort the Matlab computation, type Ctrl+C. To continue the line, type January 4, 11 Getting help. To view the online documentation, select Matlab Help from Help menu or Matlab Help directly in the command window. The preferred method is to use the Help browser. The Help browser can be started by selecting the icon from the desktop toolbar. On the other hand, information about any command is available by typing greater than help command. Another way to get help is to use the lookfor command. The lookfor command differs from the help command. The help command searches for an exact function name match, while the lookfor command searches the quick summary information in each function for the match. For example, suppose that we were looking for a function to take the inverse of a matrix. Since Matlab does not have a function named inverse, the command help inverse will produce nothing. On the other hand, the command lookfor inverse will produce detailed information, which includes the function of interest, inverse, greater than lookfor inverse. Note, at this particular time of our study, it is important to emphasize one main point. Because Matlab is a huge program, it is impossible to cover all the details of each function one by one. However, we will give you information how to get help. Here are some examples. Use online help to request info on a specific function. Greater than help sqrt. In the current version Matlab version 7, the doc function opens the online version of the help manual. This is very helpful for more complex commands. Greater than doc plot. 10. Use lookfor to find functions by keywords. The general form is greater than lookfor function m. 1.5 Exercises. Note, due to the teaching class during this fall 2005, the problems are temporarily removed from this section. 11 Chapter 2. Tutorial Lessons 2. 2.1 Mathematical Functions. Matlab offers many predefined mathematical functions for technical computing, which contains a large set of mathematical functions. Typing help elfin and help spec fun calls up full lists of elementary and special functions respectively. There is a long list of mathematical functions that are built into Matlab. These functions are called built-ins. Many standard mathematical functions, such as sin x, cos x, tan x, e, x, ln x, are evaluated by the functions sin, cos, tan, bx, and log respectively in Matlab. Table 2.1 lists some commonly used functions, where variables x and y can be numbers, vectors, or matrices. Table 2.1 Elementary functions. Cos x cosine baby s x absolute value. Sin x sine x sinum function. Tan x tangent max x maximum value. The cos x are cosine minimum x minimum value. Sin x arc sine seal x round towards +8. But an x arc tangent floor x round towards -8. Bx exponential round x round to nearest integer. Sqrt x squared root rem x remainder after division. Log x natural logarithm angle x phase angle. Log 10 x common logarithm conjunction x complex conjugate. In addition to the elementary functions, Matlab includes a number of predefined 12 constant values. A list of the most common values is given in Table 2.2. Table 2.2, Predefined constant values. Pi the key number, p equals 3.14159. ij the imaginary unit pi. v -1. Inf the infinity, 8. And not a number. 2.1.1 Examples. We illustrate here some typical examples which related to the elementary functions previously defined. As a first example, the value of the expression y equals e. 8. Sin x plus 10 dy, for a equals 5, x equals 2, and y equals 8 is computed by greater than equals 5, x equals 2, y equals 8. Greater than y equals exa asterisk sin x plus 10 asterisk sqrty y equals 28.2904. The subsequent examples are greater than log 142. They and s equals 4.9558. Greater than log 10 142. They and s equals 2.1523. Note the difference between the natural logarithm log x and the decimal logarithm base 10 log 10x. To calculate sin p/4 and e 10, we enter the following commands in Matlab. Greater than sin pi/4. They and s equals 0.7071. Greater than the x bit 10. They and s equals 2.2026 E plus 004. 13 notes. Only use built-in functions on the right-hand side of an expression. Reassigning the value to a built-in function can create problems. There are some exceptions. For example, I and j are pre-assigned to v -1. However, one or both of I or j are often used as loop indices. To avoid any possible confusion, it is suggested to use instead I or jj as loop indices. 2.2 Basic Plotting. 2.2.1 Overview. Matlab has an excellent set of graphic tools. Plotting a given dataset or the results of computation is possible with very few commands. You are highly encouraged to plot mathematical functions and results of analysis as often as possible. Trying to understand mathematical equations with graphics is an enjoyable and very efficient way of learning mathematics. Being able to plot mathematical functions and data freely is the most important step, and this section is written to assist you to do just that. 2.2. Creating simple plots. The basic Matlab graphing procedure, for example in 2D, is to take a vector of x coordinates, x equals x1, xn, and a vector of y coordinates, y equals y1. Locate the points xi, y, with I equals 1, 2, then join them by straight lines. You need to prepare x and y in an identical array form, namely, x and y are both row arrays or column arrays of the same length. The Matlab command to plot a graph is plot xy. The vectors x equals 1, 2, 3, 4, 5, 6, and y equals 3, -1, 2, 4, 5, 1 produce the picture shown in figure 2.1. Greater than x equals 1, 2, 3, 4, 5, 6. Greater than y equals 3, -1, 2, 4, 5, 1. Greater than plot xy. Note, the plot functions has different forms depending on the input arguments. If y is a vector, plot y produces a piecewise linear graph of the elements of y versus the index of the elements of y. If we specify two vectors, as mentioned above, plot xy produces a graph of y versus x. For example, to plot a function sin x on the interval 0 to p, we first create a vector of x values ranging from 0 to 2p, then compute the sign of these values, and finally plot the result. 14 1 2 3 4 5 6 -1 0 1 2 3 4 5. Figure 2.1. Plot for the vectors x and y. Greater than x equals 0 pi / 100 2 asterisk pi. Greater than y equals sin x. Greater than plot xy. Notes: 0 pi / 100 2 asterisk pi yields a vector that starts at 0, takes steps or increments of p / 100, stops when 2p is reached. If you omit the increment, Matlab automatically increments by 1. 2.2.3 Adding titles, axis labels, and annotations. Matlab enables you to add axis labels and titles. For example, using the graph from the previous example, add an x and y-axis labels. Now label the axis and add a title. The character \pi creates the symbol p. An example of 2D plot is shown in figure 2.2. 15 0 1 2 3 4 5 6 7. -1, -0.8, -0.6, -0.4, -0.2, 0, 0.2, 0.4, 0.6, 0.8, 1. X equals 0 2p. Sign of x. Plot of the sine function. Figure 2.2. Plot of the sine function. Greater than equal x equals 0 to \pi. Greater than bell sign of x. Greater than titled plot of the sine function. The color of a single curve is, by default, blue, but other colors are possible. The desired color is indicated by a third argument. For example, red is selected by plot xy. Note: the single quotes around are 2.2. for multiple datasets in one plot. Multiple x Y pairs arguments create multiple graphs with a single call to plot. For example, these statements plot three related functions of x, y1 equals to cos x, y2 equals cos x, and y3 equals 0.5 asterisk cos x, in the interval 0 equals x equals to p, greater than x equals 0 colon pi slash 100 colon 2 asterisk pi, greater than y1 equals 2 asterisk cos x, greater than y2 equals cos x, greater than y3 equals 0.5 asterisk cos x, greater than plot xy1 xy2 xy3, greater than equal 0 backslash log q x backslash log q to backslash pi, greater than delabel cosine functions, greater than legend to asterisk cos x 0.5 asterisk cos x. 16 greater than titled typical example of multiple plots, greater than axis 0 to asterisk pi negative 3. The result of multiple datasets in one graph plot is shown in figure 2.3. 0 1 2 3 4 5 6 negative 3 negative 2 negative 1 0 1 2 3 0 equals x equals to p. Cosine functions. Typical example of multiple plots. 2 asterisk cos x 0.5 asterisk cos x. Figure 2.3. Typical example of multiple plots. By default, Matlab uses line style and color to distinguish the datasets plotted in the graph. However, you can change the appearance of these graphic components or add annotations to the graph to help explain your data for presentation. 2.2.5 Specifying line styles and colors. It is possible to specify line styles, colors, and markers, e.g., circles, plus signs, using the plot command. Plot xy style underscore color underscore marker, where style underscore color underscore marker is a triplet of values from table 2.3. To find additional information, type help plot or doc plot. 17 Table 2.3 Attributes for plot. Symbol color symbol line style symbol marker. K black, solid plus sign. R red, dash toe circle. B blue, dotted asterisk. G green, dash dot. Point. C cyan none no line cross. M magenta S square. Y yellow D diamond. 2.3 Exercises. Note, due to the teaching class during this fall quarter 2005, the problems are temporarily removed from this section. 18 2.4 Introduction. Matrices are the basic elements of the Matlab environment. A matrix is a two-dimensional array consisting of m rows and n columns. Special cases are column vectors n equals 1 and row vectors m equals 1. In this section we will illustrate how to apply different operations on matrices. The following topics are discussed: vectors and matrices in Matlab, the inverse of a matrix, determinants, and matrix manipulation. Matlab supports two types of operations, known as matrix operations and array operations. Matrix operations will be discussed first. 2.5 Matrix generation. Matrices are fundamental to Matlab. Therefore, we need to become familiar with matrix generation and manipulation. Matrices can be generated in several ways. 2.5.1 Entering a vector. A vector is a special case of a matrix. The purpose of this section is to show how to create vectors and matrices in Matlab. As discussed earlier, an array of dimension 1 n is called the row vector, whereas an array of dimension m1 is called a column vector. The elements of vectors in Matlab are enclosed by square brackets and are separated by spaces or by commas. For example, to enter the row vector, v, type greater than v equals 1 for 7 10 13, v equals 1 for 7 10 13. Column vectors are created in a similar way, however, semicolon must separate the components of a column vector. Greater than w equals 1 for 7 10 13, w equals 1 for 7 10 13. On the other hand, the row vector is converted to a column vector using the transpose operator. The transpose operation is denoted by an apostrophe or a single quote. 19 greater than W equals V, W equals 1, 4, 7, 10, 13. Thus, V1 is the first element of vector V, V2 its second element, and so forth. Furthermore, to access blocks of elements, we use Matlab's colon notation. For example, to access the first three elements of V, we write greater than V1 colon 3, they and S equals 1 for 7, or all elements from the third through the last elements, greater than V3 and they and S equals 7, 10, 13, where and signifies the last element in the vector. If V is a vector, writing greater than V produces a column vector, whereas a writing greater than V1 colon and produces a row vector. 2.5. Entering a matrix. A matrix is an array of numbers. To type a matrix into Matlab you must begin with a square bracket, separate elements in a row with spaces or commas, use a semicolon to separate rows, and the matrix with another square bracket. 20. Here is a typical example. To enter a matrix say, such as E equals 1 2 3 4 5 6 7 8 9 2.1, type greater than or equals 1 2 3 4 5 6 7 8 9. Matlab then displays the 3-3 matrix as follows. E equals 1 2 3 4 5 6 7 8 9. Note that the use of semicolons here is different from their use mentioned earlier to suppress output or to write multiple commands in a single line. Once we have entered the matrix, it is automatically stored and remembered in the workspace. We can refer to it simply as matrix A. We can then view a particular element in a matrix by specifying its location. We write greater than 8 to 1, they and S equals 4. 8 to 1 is an element located in the second row and first column. Its value is 4. 2.5.3 Matrix indexing. We select elements in a matrix just as we did for vectors, but now we need two indices. The element of row I and column J of the matrix A is denoted by AIJ. Thus, AIJ in Matlab refers to the element AJ of matrix A. The first index is the row number and the second index is the column number. For example, A13 is an element of first row and third column. Here, A13 equals 3. Correcting any entry is easy through indexing. Here we substitute A33 equals 9 by A33 equals 0. The result is greater than A33 equals 0. E equals 1 2 3 4 5 6 7 8 0. 21 single elements of a matrix are accessed as IJ, where I equals 1 and J equals 1, 0 or negative. Subscripts are not supported in Matlab. 2.5.4 colon operator. The colon operator will prove very useful, and understanding how it works is the key to efficient and convenient usage of Matlab. It occurs in several different forms. Often we must deal with matrices or vectors that are too large to enter one element at a time. For example, suppose we want to enter a vector x consisting of points 0, 0.1, 0.2, 0.3, 5. We can use the command greater than x equals 0 colon 0.1 colon 5. The row vector has 51 elements. 2.5.5 Linear spacing. On the other hand, there is a command to generate linearly spaced vectors, linspace. It is similar to the colon operator but gives direct control over the number of points. For example, y equals linspace AB generates a row vector y of 100 points linearly spaced between and including A and B. Y equals linspace ABN generates a row vector y of n points linearly spaced between and including A and B. This is useful when we want to divide an interval into a number of subintervals of the same length. For example, greater than data equals linspace 0 to asterisk pi 101. Divide the interval 0 to p into 100 equal subintervals, then creating a vector of 101 elements. 2.5.6 colon operator in a matrix. The colon operator can also be used to pick out a certain row or column. For example, the Statement AM:NK:L specifies rows M to N and column K to L. Subscript expressions refer to portions of a matrix. For example, 22 greater than A2, they and S equals 4, 5, 6 is the second row elements of A. The colon operator can also be used to extract a submatrix from a matrix A. Greater than A colon to colon 3, they and S equals 2, 3, 5, 6, 8, 0. A colon to colon 3 is a submatrix with the last two columns of A. The row or a column of a matrix can be deleted by setting it to a null vector. Greater than A colon 2 equals, they and S equals 1, 3, 4, 6, 7, 0, 2.5.7 creating a submatrix. To extract a submatrix B consisting of rows 2 and 3 and columns 1 and 2 of the matrix A, do the following. Greater than B equals A2 3 1 2, B equals 4 5, 7 8. To interchange rows 1 and 2 of A, use the vector of row indices together with the colon operator. Greater than C equals A2 1 3, C equals 4 5 6, 1 2 3, 7 8 0. It is important to note that the colon operator stands for all columns or all rows. 2. Create a vector version of matrix A, do the following. 23 greater than A, they and S equals 1, 2, 3, 4, 5, 6, 7, 8, 0. The submatrix comprising the intersection of rows P to Q and columns R to S is denoted by AP:QR:S. As a special case, the colon as the row or column specifier covers all entries in that row or column. Thus, A:(J) is the JDH column of A, while AI is the th row, and they and picks out the last row of A. The keyword and used in A and denotes the last index in the specified dimension. Here are some examples. Greater than A, E equals 1 2 3, 4 5 6, 7 8 9. Greater than A2 colon 3 to colon 3, they and S equals 5 6, 8 9. Greater than A and colon 1 and they and S equals 9 6 3, 24. Greater than A1 3 to 3, they and S equals 2 3, 8 9. 2.5.8 Deleting row or column. To delete the row or column of a matrix, use the empty vector operator. Greater than A3 equals, E equals 1 2 3, 4 5 6. Third row of matrix A is now deleted. To restore the third row, we use a technique for creating a matrix. Greater than equals A1 colon A2 colon 7 8 0. E equals 1 2 3, 4 5 6, 7 8 0. Matrix A is now restored to its original form. 2.5.9 Dimension. To determine the dimensions of a matrix or vector, use the command size. For example, greater than size A, they and S equals 3 3, means 3 rows and 3 columns. Or more explicitly with greater than M and equals size A, 25 February 5th 10 continuation. If it is not possible to type the entire input on the same line, use consecutive periods, called an ellipsis. To signal continuation, then continue the input on the next line. B equals 4/5 7.23 asterisk tan x sqrt 6. 1/x circumflex accent to 03/x asterisk log x. x7 sqrt 3x asterisk sin x. Note that blank spaces around plus equals signs optional, but they improve readability. February 5th 11 Transposing a matrix. The transpose operation is denoted by an apostrophe or a single quote. It flips a matrix about its main diagonal and it turns the row vector into a column vector. Thus, greater than A, they and S equals 1 4 7, 2 5 8, 3 6 0. By using linear algebra notation, the transpose of an n-real matrix A is the n-a matrix that results from interchanging the rows and columns of A. The transpose matrix is denoted at February 5th 12 concatenating matrices. Matrices can be made up of submatrices. Here is an example. First, let's recall our previous matrix A. E equals 1 2 3 4 5 6 7 8 9. The new matrix B will be greater than B equals a 10 asterisk A, A1 0 0 0 1 0 0 0 1. B equals 1 2 3 10 20 30 26 4 5 6 40 50 60 7 8 9 70 80 90. Negative 1 negative 2 negative 3 1 0 0. Negative 4 negative 5 negative 6 0 1 0. Negative 7 negative 8 negative 9 0 0 1. February 5th 13 matrix generators. Matlab provides functions that generates elementary matrices. The matrix of zeros, the matrix of ones, and the identity matrix are returned by the functions zeros, ones, and I, respectively. Table 2.4 Elementary matrices. IMN returns an m by n matrix with 1 on the main diagonal. IN returns an n by n squared identity matrix. Zeros mn returns an m by n matrix of zeros. Ones mn returns an m by n matrix of ones. Diagram A extracts the diagonal of matrix A. Random n returns an m by n matrix of random numbers. For a complete list of elementary matrices and matrix manipulations, type help element or doc element. Here are some examples. 1. Greater than B equals 1 3 1. B equals 1 1 1. Equivalently, we can define B as greater than B equals 1 1 1. 2. Greater than I 3. A and S equals 1 0 0 0 1 0 0 0 1. 3. Greater than C equals 0s to 3. C equals 0 0 0 27 0 0 0. In addition, it is important to remember that the three elementary operations of addition, plus subtraction and multiplication asterisk apply also to matrices whenever the dimensions are compatible. Two other important matrix generation functions are rand and random, which generate matrices of pseudo-random numbers using the same syntax as I. In addition, matrices can be constructed in a block form, with C defined by C equals 1, 2, 3 4. We may create the matrix D as follows. Greater than D equals C zeros to 1s to I2. D equals 1 2 0 0 3 4 0 0 1 1 1 0 1 1 0 1. February 5th 14 Special matrices. Matlab provides a number of special matrices. See Table 2.5. These matrices have interesting properties that make them useful for constructing examples and for testing algorithms. For more information, see Matlab documentation. Table 2.5 Special matrices. Hilbert matrix. Inverse Hilbert matrix. Magic square. Pascal matrix. Matrix. Vanderman matrix. Wilkinson's eigenvalue test matrix. 28 2.6 Exercises. Note, due to the teaching class during this fall quarter 2005, the problems are temporarily removed from this section. 29 Chapter 3. Array operations and linear equations. 3.1 Array operations. Matlab has two different types of arithmetic operations: matrix arithmetic operations and array arithmetic operations. We have seen matrix arithmetic operations in the previous lab. Now, we are interested in array operations. 3.1.1 Matrix arithmetic operations. As we mentioned earlier, Matlab allows arithmetic operations, plus, asterisk, and circumflex accent to be carried out on matrices. Thus, A plus B or B plus A is valid if A and B are of the same size. A asterisk B is valid if A's number of column equals B's number of rows. A circumflex accent to is valid if A is square and equals A asterisk K. A asterisk K or A asterisk K multiplies each element of A by 8. 3.1.2 Array arithmetic operations. On the other hand, array arithmetic operations or array operations for short, are done element by element. The period character distinguishes the array operations from the matrix operations. However, since the matrix and array operations are the same for addition, plus and subtraction, the character pairs dot plus and are not used. The list of array operators is shown below in Table 3.2. If A and B are two matrices of the same size with elements A equals AJ and B equals BJ, then the command 30 element by element multiplication element by element division circumflex accent element by element exponentiation. Table 3.1 Array operators. Greater than C equals A B produces another matrix C of the same size with elements C at J equals AJ BJ. For example, using the same 3 matrices, E equals 1 2 3 4 5 6 7 8 9, B equals 10 20 30 40 50 60 70 80 90. We have greater than C equals A B. C equals 10 40 90. Area code 160250360. Area code for 906400810. To raise a scalar to a power, we use for example the command 10 circumflex accent 2. If we want the operation to be applied to each element of a matrix, we use circumflex accent 2. For example, if we want to produce a new matrix whose elements are the square of the elements of the matrix A, we enter greater than 8 circumflex accent 2. A and S equals 149 16 25 36 49 64 81. The relations below summarize the above operations. To simplify, let's consider two vectors U and V with elements U equals UI and V equals VJ. U asterisk V produces U1 V1 U V2. On Vn, U dot slash V produces U1 slash V1 U slash V2. On slash Vn, U dot circumflex accent V produces U V1 1 U V2 2 of Vn. Then 31 operation matrix array. Addition plus subtraction, multiplication asterisk dot asterisk, division slash dot slash, left division backslash dot backslash, exponentiation circumflex accent dot circumflex accent. Table 3.2 Summary of matrix and array operations. 3.2 Solving linear equations. One of the problems encountered most frequently in scientific computation is the solution of systems of simultaneous linear equations. With matrix notation, the system of simultaneous linear equations is written x equals b 3.1, where there are as many equations as unknown. A is a given square matrix of order n, b is a given column vector of n components, and x is an unknown column vector of n components. In linear algebra we learned that the solution to x equals b can be written as x equals a1 b, where a1 is the inverse of a. For example, consider the following system of linear equations. X plus 2y plus 3z equals 1. 4x plus 5y plus 6z equals 1. 7x plus 8y equals 1. The coefficient matrix A is E equals 1 2 3 4 5 6 7 8 9, and the vector B equals 1 1 1. With matrix notation, the system of simultaneous linear equations is written x equals b 3.2. This equation can be solved for x using linear algebra. The result is x equals a1 b. There are typically two ways to solve for x in Matlab. 1. The first one is to use the matrix inverse 30 to greater than or equals 1 2 3 4 5 6 7 8 0. Greater than b equals 1 1 1. Greater than x equals inverse a asterisk b. X equals negative 1.0000, 1.0000, negative 0.0000. 2. The second one is to use the backslash operator, the numerical algorithm behind this operator is computationally efficient. This is a numerically reliable way of solving system of linear equations by using a well-known process of Gaussian elimination. Greater than or equals 1 2 3 4 5 6 7 8 0. Greater than b equals 1 1 1. Greater than x equals a backslash b. X equals negative 1.0000, 1.0000, negative 0.0000. This problem is at the heart of many problems in scientific computation. Hence it is important that we know how to solve this type of problem efficiently. Now, we know how to solve a system of linear equations. In addition to this, we will see some additional details which relate to this particular topic. 3.1 Matrix inverse. Let's consider the same matrix A. E equals 1 2 3 4 5 6 7 8 0. Calculating the inverse of A manually is probably not a pleasant work. Here the hand calculation of A1 gives as a final result 8, negative 1 equals 1, 9, negative 16 8 negative 1, 14 negative 7 2, negative 1 2 negative 1. In Matlab, however, it becomes as simple as the following commands. 33 greater than equals 1 2 3 4 5 6 7 8 0. Greater than inverse A. A and S equals negative 1.7778 negative 0.1111, 1.5556 negative 0.7778 0.2222, negative 0.1111 0.2222 negative 0.1111, which is similar to 8, negative 1 equals 1, 9, negative 16 8 negative 1, 14 negative 7 2, negative 1 2 negative 1, and the determinant of A is greater than div 8. A and S equals 27. For further details on applied numerical linear algebra, see 10 and 11. 3.2 Matrix functions. Matlab provides many matrix functions for various matrix/vector manipulations. See Table 3.3 for some of these functions. Use the online help of Matlab to find how to use these functions. Lit determinant. Diagram diagonal matrices and diagonals of a matrix. Big eigenvalues and eigenvectors. Inverse matrix inverse. Norm matrix and vector norms. Rank number of linearly independent rows or columns. Table 3.3, Matrix functions. 3.3 Exercises. Note, due to the teaching class during this fall quarter 2005, the problems are temporarily removed from this section. 34 Chapter 4. Introduction to Programming in Matlab. 4.1 Introduction. So far in these lab sessions, all the commands were executed in the command window. The problem is that the commands entered in the command window cannot be saved and executed again for several times. Therefore, a different way of executing repeatedly commands with Matlab is 1. To create a file with a list of commands. 2. Save the file, and 3. Run the file. If needed, corrections or changes can be made to the commands in the file. The files that are used for this purpose are called script files or scripts for short. This section covers the following topics. File scripts. File functions. 4.2 Meter file scripts. A script file is an external file that contains a sequence of Matlab statements. Script files have a file name extension .m and are often called M files. M files can be scripts that simply execute a series of Matlab statements, or they can be functions that can accept arguments and can produce one or more outputs. 35 for .2.1 examples. Here are two simple scripts. Example 1. Consider the system of equations. X plus 2y plus 3z equals 1. 3x plus 3y plus 4z equals 1. 2x plus 3y plus 3z equals 2. Find the solution X to the system of equations. Solution. Use the Matlab editor to create a file. New. M file. Enter the following statements in the file. E equals 1 2 3, 3 3 4, 2 3 3. B equals 1, 1, 2. X equals a backslash b. Save the file, For example, example1.m. Run the file, in the command line, by typing greater than example1. X equals negative 0.5000, 1.5000, negative 0.5000. When execution completes, the variables a, b, and x remain in the workspace. To see a listing of them, enter whos at the command prompt. Note, the Matlab editor is both a text editor specialized for creating AMP files and a graphical Matlab debugger. The Matlab editor has numerous menus for tasks such as saving, viewing, and debugging. Because it performs some simple checks and also uses color to differentiate between various elements of codes, this text editor is recommended as the tool of choice for writing and editing AMP files. There is another way to open the editor. 36 greater than edit, or greater than edit filename.m. To open filename.m. Example 2. Plot the following cosine functions: y1 equals to cos x, y2 equals cos x, and y3 equals 0.5 asterisk cos x, in the interval 0 equals x equals to p. This example has been presented in previous chapter. Here we put the commands in a file. Create a file, say example2.m, which contains the following commands: x equals 0:pi/100:2 asterisk pi, y1 equals 2 asterisk cos x, y2 equals cos x, y3 equals 0.5 asterisk cos x. Plot xy1 xy2 xy3. Declar bell 0 \lq x \lq to \pi. Delete bell cosine functions. Legend 2 asterisk cos x 0.5 asterisk cos x. Title typical example of multiple plots. Axis 0 to asterisk pi negative 3. Run the file by typing example2 in the command window. For script side effects, all variables created in a script file are added to the workspace. This may have undesirable effects, because variables already existing in the workspace may be overwritten. The execution of the script can be affected by the state variables in the workspace. As a result, because scripts have some undesirable side effects, it is better to code any complicated applications using rather function m file. 37 4.3 meters file functions. As mentioned earlier, functions are programs or routines that accept input arguments and return output arguments. Each m file function or m file for short has its own area of workspace, separated from the Matlab base workspace. For 3.1 Anatomy of a m file function. This simple function shows the basic parts of an m file. Function f equals factorial n1. Factorial n returns the factorial of n2. Compute a factorial value. 3. F equals prod1:n. For the first line of a function m file starts with the keyword function. It gives the function name and order of arguments. In the case of function factorial, there are up to one output argument and one input argument. Table 4.1 summarizes the m file function. As an example, for n equals 5, the result is greater than f equals factorial 5, f equals 120. Table 4.1, Anatomy of a m file function. Part number m file element description. One function define the function name, and the definition number and order of input and line output arguments. To H1 line the one-line summary description of the program, displayed when you request help. 3 help text the more detailed description of the program. For function body program code that performs the actual computations. Both functions and scripts can have all of these parts, except for the function definition line which applies to function only. 38 In addition, it is important to note the function name must begin with a letter, and must be no longer than the maximum of 63 characters. Furthermore, the name of the text file that you save will consist of the function name with the extension .m. Thus, the above example file would be factorial.m. Table 4.2 summarizes the differences between scripts and functions. Table 4.2 Difference between scripts and functions. Scripts functions do not accept input, can accept input arguments and arguments or return output arguments. Arguments. Store variables in a. Store variables in a workspace. Workspace that is shared internal to the function with other scripts. Are useful for automating, are useful for extending the Matlab. The series of commands language for your application. 39 4.3. Input and output arguments. As mentioned above, the input arguments are listed inside parentheses following the function name. The output arguments are listed inside the brackets on the left side. They are used to transfer the output from the function file. The general form looks like this. Function outputs equals function underscore name inputs. Function file can have none, one, or several output arguments. Table 4.3 illustrates some possible combinations of input and output arguments. Table 4.3, example of input and output arguments. Function C equals ftuck f1 input argument and 1 output argument. Function area equals trajectory a bh3 inputs and 1 output. Function HV equals motion v angle 2 inputs and 2 outputs. 4.4 Input to a script file. When a script file is executed, the variables that are used in the calculations within the file must have assigned values. The assignment of a value to a variable can be done in 3 ways. 1. The variable is defined in the script file. 2. The variable is defined in the command prompt. 3. The variable is entered when the script is executed. We have already seen the 2 first cases. Here, we will focus our attention on the third one. In this case, the variable is defined in the script file. When the file is executed, the user is prompted to assign a value to the variable in the command prompt. This is done by using the input command. Here is an example. This script file calculates the average of points scored in 3 games. The point from each game are assigned to a variable by using the input command. Game 1 equals input enter the points scored in the first game. 40 Game 2 equals input enter the points scored in the second game. Game 3 equals input enter the points scored in the third game. Average equals Game 1 plus Game 2 plus Game 3/3. The following shows the command prompt when this script file saved as example 3 is executed. Greater than example 3. Greater than enter the points scored in the first game 15. Greater than enter the points scored in the second game 23. Greater than enter the points scored in the third game 10. Average equals 16. The input command can also be used to assign string to a variable. For more information, see Matlab documentation. A typical example of in-file function programming can be found in a recent paper which related to the solution of the ordinary differential equation code 12. 4.5 Output commands. As discussed before, Matlab automatically generates a display when commands are executed. In addition to this automatic display, Matlab has several commands that can be used to generate displays or outputs. 2 commands that are frequently used to generate output are dispensary and fprintf. The main differences between these 2 commands can be summarized as follows. Table 4.4. Table 4.4, Dispensary and fprintf commands. Dispensary. Simple to use. Provide limited control over the appearance of output. Fprintf. Slightly more complicated than dispensary. Provide total control over the appearance of output. 41 4.6 Exercises. 1. Liz buys 3 apples, a dozen bananas, and 1 cantaloupe for $2.36. Bob buys a dozen apples and 2 cantaloupe for $5.26. Carol buys 2 bananas and 3 cantaloupe for $2.77. How much do single pieces of each fruit cost? 2. Write a function file that converts temperature in degrees Fahrenheit F to degrees centigrade C. Use input and fprintf commands to display a mix of text and numbers. Recall the conversion formulation, C equals 5/9 F, 32. 3. Write a user-defined Matlab function, with 2 input and 2 output arguments. that determines the height in centimeters and mass in kilograms of a person, from his height in inches and weight in pounds. A. Determine in SI units the height and mass of a 5 feet. 15 in person who weight 180 pounds. B. Determine your own height and weight in SI units. 42. Chapter 5. Control flow and operators. 5.1 Introduction. Matlab is also a programming language. Like other computer programming languages, Matlab has some decision-making structures for control of command execution. These decision-making or control flow structures include for loops, while loops, and if-else end constructions. Control flow structures are often used in script M files and function M files. By creating a file with the extension .m, we can easily write and run programs. We do not need to compile the program since Matlab is an interpretative not compiled language. Matlab has thousands of functions, and you can add your own using M files. Matlab provides several tools that can be used to control the flow of a program, script or function. In a simple program as shown in the previous chapter, the commands are executed one after the other. Here we introduce the flow control structure that make possible to skip commands or to execute specific group of commands. 5.2 Control flow. Matlab has for control flow structures, the if statement, the for loop, the while loop, and the switch statement. 5.1 The if end structure. Matlab supports the variants of if construct, if end, if else end. 43 If else else end. The simplest form of the if statement is if expression statements. And here are some examples based on the familiar quadratic formula. 1. TCR equals the asterisk B, for asterisk A asterisk C. Dispensary warning, discriminate is negative, roots are imaginary. And 2. TCR equals the asterisk B, for asterisk A asterisk C. Dispensary warning, discriminate is negative, roots are imaginary. Else, dispensary roots are real, but may be repeated. And 3. TCR equals the asterisk B, for asterisk A asterisk C. Dispensary warning, discriminate is negative, roots are imaginary. Else if TCR equals 0. Dispensary discriminate is 0, roots are repeated. Else, dispensary roots are real. And it should be noted that else if has no space between else and if one word. No semicolon is needed at the end of lines containing if, else, and indentation of a block is not required, but facilitate the reading. The end statement is required. 44 5.2 Relational and logical operators. The relational operator compares two numbers by determining whether a comparison is true or false. Relational operators are shown in Table 5.1. Table 5.1, Relational and logical operators. Operator description. Greater than equals greater than or equal to, equal to, tilde equals not equal to, and operator. Vertical line or operator, tilde not operator. Note that the equal to relational operator consists of two equal signs equals with no space between them, since equals is reserved for the assignment operator. 5.2.3 The for ... end loop. In the for end loop, the execution of a command is repeated at a fixed and predetermined number of times. The syntax is for variable equals expression statements. And usually, expression is a vector of the form I:(s:(j). A simple example of for loop is for I equals 1:5, x equals I asterisk I. And it is a good idea to indent the loops for readability, especially when they are nested. Note that Matlab editor does it automatically. Multiple for loops can be nested, in which case indentation helps to improve the readability. The following statements form the 5x5 symmetric matrix O with I, j element, I/j for j equals I, 45 n equals 5, e equals I n, for j equals 2:n, for I equals 1:j1, say ij equals I/j, aj equals I/j, and 5.2.4 The while ... end loop. This loop is used when the number of passes is not specified. The looping continues until a stated condition is satisfied. The while loop has the form while expression statements, and the statements are executed as long as the expression is true. X equals 1, X equals 3 asterisk X, and it is important to note that if the condition inside the looping is not well defined, the looping will continue indefinitely. If this happens, we can stop the execution by pressing Ctrl C. 5.5 Other flow structures. The break statement. The while loop can be terminated with the break statement, which passes control to the first statement after the corresponding end. The break statement can also be used to exit a for loop. The continue statement can also be used to exit a for loop to pass immediately to the next iteration of the loop, skipping the remaining statements in the loop. Other control statements include return, continue, switch, etc. For more detail about these commands, consult Matlab documentation. 46 5.2.6 Operator precedence. We can build expressions that use any combination of arithmetic, relational, and logical operators. Precedence rules determine the order in which Matlab evaluates an expression. We have already seen this in the tutorial lessons. Here we add other operators in the list. The precedence rules for Matlab are shown in this list. Table 5.2 ordered from highest 1 to lowest 9 precedence level. Operators are evaluated from left to right. Table 5.2 Operator precedence. Precedence operator 1 parenthesis. To transpose 0. Power dot circumflex accent matrix power circumflex accent 3 unary plus unary minus logical negation tilde. For multiplication asterisk right division slash left division dot backslash matrix multiplication asterisk matrix right division slash matrix left division backslash 5 addition plus subtraction 6 operator 7 less than greater than or equal to not equal to tilde equals 8 element wise and 9 element wise or vertical line. 5.3 Saving output to a file. In addition to displaying output on the screen, the command fprintf can be used for writing the output to a file. The saved data can subsequently be used by Matlab or other softwares. To save the results of some computation to a file in a text format requires the following steps. 1. Open a file using fprintf. 2. Write the output using fprintf. 3. Close the file using fclose. Here is an example script of its use. 47% write some variable length strings to a file. Opus equals fprintf weekdays.txt fprintf opus Sunday backslash n Monday backslash n Tuesday backslash n next backslash n fprintf opus Thursday backslash n Friday backslash n Saturday backslash n fclose opus. This file weekdays.txt can be opened with any program that can read .txt file. 5.4 Exercises. Note: due to the teaching class during this fall quarter 2005, the problems are temporarily removed from this section. 48 Chapter 6. Debugging AMP files. 6.1 Introduction. This section introduces general techniques for finding errors in AMP files. Debugging is the process by which you isolate and fix errors in your program or code. Debugging helps to correct two kinds of errors. Syntax errors, for example omitting a parenthesis or misspelling a function name. Runtime errors. Runtime errors are usually apparent and difficult to track down. They produce unexpected results. 6.2 Debugging process. We can debug the AMP files using the editor/debugger as well as using debugging functions from the command window. The debugging process consists of preparing for debugging, setting breakpoints, running an AMP file with breakpoints, stepping through an AMP file, examining values, correcting problems, ending debugging. 49 6.2.1 Preparing for debugging. Here we use the editor/debugger for debugging. Do the following to prepare for debugging. Open the file. Save changes. Be sure the file you run and any files it calls are in the directories that are on the search path. 6.2. Setting breakpoints. Set breakpoints to pause execution of the function, so we can examine where the problem might be. There are three basic types of breakpoints. The standard breakpoint, which stops at a specified line. The conditional breakpoint, which stops at a specified line and under specified conditions. An error breakpoint that stops when it produces the specified type of warning, error, NaN, or infinite value. You cannot set breakpoints while Matlab is busy, for example, running an M file. 6.2.3 Running with breakpoints. After setting breakpoints, run the M file from the editor/debugger or from the command window. Running the M file results in the following. The prompt in the command window changes to K greater than, indicating that Matlab is in debug mode. The program pauses at the first breakpoint. This means that line will be executed. When you continue, the pause is indicated by the green arrow. In breakpoint, we can examine variable, step through programs, and run other calling functions. 56.2.4 Examining values. While the program is paused, we can view the value of any variable currently in the workspace. Examine values when we want to see whether a line of code has produced the expected result or not. If the result is as expected, step to the next line, and continue running. If the result is not as expected, then that line, or the previous line, contains an error. When we run the program, the current workspace is shown in the stack field. Use who or whos to list the variables in the current workspace. Viewing values as data tips. First, we position the cursor to the left of a variable on that line. Its current value appears. This is called the data tip, which is like the tool tip for data. If you have trouble getting the data tip to appear, click in the line and then move the cursor next to the variable. 6.2.5 Correcting and ending debugging. While debugging, we can change the value of a variable to see if the new value produces expected results. While the program is paused, assign a new value to the variable in the command window, workspace browser, or array editor. Then continue running and stepping through the program. 6.2.6 Ending debugging. After identifying the problem, end the debugging session. It is best to quit debug mode before editing an M file. Otherwise, you can get unexpected results when you run the file. To end debugging, select Exit Debug Mode from the Debug menu. 6.2.7 Correcting an M file. To correct errors in an M file, quit debugging. Do not make changes to an M file while Matlab is in debug mode. Make changes to the M file. Save the M file. Clear breakpoints. 51 Run the M file again to be sure it produces the expected results. For details on debugging process, see Matlab documentation. 52 Appendix A. Summary of commands. Table A.1 Arithmetic operators and special characters. Character description. Plus addition, subtraction, asterisk multiplication, scalar and array, slash division right, circumflex accent power or exponentiation, colon, creates vectors with equally spaced elements, semicolon, suppresses display, hence row in array, comma, separates array subscripts, continuation of lines, %% denotes a comment, specifies output format, 0 single quote, creates string, specifies matrix transpose, equals assignment operator, parentheses, encloses elements of arrays and input arguments, brackets, encloses matrix elements and output arguments. 53 Table A.2 Array operators. Character description. Asterisk array multiplication. Array right division. Circumflex accent array power. Array left division. 0 Array non-conjugated transpose. Table A.3 Relational and logical operators. Character description. Equals less than or equal to. Greater than. Equals greater than or equal to. Equals equal to. Tilde equals not equal to. And logical or element-wise and. Vertical line logical or element-wise or. And short circuit and. Vertical line short circuit or. 54 Table A.4 Managing workspace and file commands. Command description. cd change current directory. CLC clear the command window. Clear all removes all variables from the workspace. Clear X remove X from the workspace. Copy file or directory. Delete files. Directory display directory listing. Exist check if variables or functions are defined. Help display help for Matlab functions. Look at for search for specified word in all help entries. Imcator make new directory. Move file or directory. PWD identify current directory. RMD remove directory. Type display contents of file. What list Matlab files in current directory. Which locate functions and files. Who display variables currently in the workspace. Whose display information on variables in the workspace. Table A.5 predefined variables and map constants. Variable description. The and s value of last variable answered. BPS floating point relative accuracy. I imaginary unit of a complex number. INF infinity 8. BPS floating point relative accuracy. J imaginary unit of a complex number. NAND not a number. Pipe the number P3.14159. 55 Table A.6 Elementary matrices and arrays. Command description. I identity matrix. Lin space generate linearly space vectors. Ones create array of all ones. Rand uniformly distributed random numbers and arrays. Zeros create array of all zeros. Table A.7 Arrays and matrices. Basic information. Command description. Dispensary display text or array. ISOMT determine if input is empty matrix. Size equal test arrays for equality. Length of vector. Endians number of dimensions. Numeral number of elements. Size of matrix. Table A.8 Arrays and matrices. Operations and manipulation. Command description. Cross vector cross product. Diagram diagonal matrices and diagonals of matrix. Dot vector dot product. Bend indicate last index of array. Find indices of non-zero elements. Cron netter tensor product. Maximum value of array. Minimum value of array. Product of array elements. Reshape array. Sort array elements. Sum of array elements. Size of matrix. 56 Table A.9 Arrays and matrices. Matrix analysis and linear equations. Command description. Condition number with respect to inversion. Bit determinant. Inverse matrix inverse. Lin solve linear system of equations. Lutetium factorization. Norm matrix or vector norms. Null space. Orthogonalization. Rank matrix rank. RF reduced row echelon form. Trace sum of diagonal elements. 57 Appendix B. Release notes for Release 14 with Service Pack 2. B.1 Summary of changes. Matlab 7 Release 14 with Service Pack 2 R14 SP2 includes several new features. The major focus of R14 SP2 is on improving the quality of the product. This document doesn't attempt to provide a complete specification of every single feature, but instead provides a brief introduction to each of them. For full details, you should refer to the Matlab documentation release notes. The following key points may be relevant. 1. Spaces before numbers, for example, *.5, you will typically get a mystifying message saying that it was previously used as a variable. There are two workarounds. A. Remove all the spaces. *.5. B. Or, put a 0 in front of the dot. The *0.5. 2. RHS empty matrix. The right-hand side must literally be the empty matrix. It cannot be a variable that has the value as shown here. RHS equals A:2 equals RHS. Subscript assignment dimension mismatch. 58.3. New format option. We can display Matlab output using two new formats. Short and long art. Short displays output in engineering format that has at least 5 digits and the power that is a multiple of 3. Greater than format short greater than pipe. The and s equals 3.1416 e plus 000. Long displays output in engineering format that has 16 significant digits, and a power that is a multiple of 3. Greater than format long at greater than pipe. A and S equals 3.14,159,265,358,979 plus 000. For help, to get help for a subfunction, use greater than help function underscore name greater than subfunction underscore name. In previous versions, the syntax was greater than help function underscore name slash subfunction underscore name. This change was introduced in R14 Matlab 7.0 but was not documented. Use the MathWorks website search features to look for the latest information. 5. Publishing to LaTeX no respects the image file type you specify in preferences. Rather than always using ETSC2 files, the publish image options in editor/debugger preferences for publishing images have changed slightly. The changes prevent you from choosing invalid formats. The files created when publishing using cells now have more natural extensions. For example, JPEG files now have a .jpg instead of a .jpeg extension, and ETSC2 files now have an .eps instead of an .fsc2 extension. Notebook will no longer support Microsoft Word 97 starting in the next release of MATLAB. 6. Debugging. Go directly to a subfunction for using the enhanced Go to dialog box. Click the name column header to arrange the list of functions alphabetically, or click the line column header to arrange the list by the position of the functions in the file. 59b.2 Other changes. 1. There is a new command element, which will scan a file and show inefficiencies in the code. For example, it will tell you if you defined a variable you've never used, if you failed to pre-allocate an array, etc. These are common mistakes in EA1 which produce runnable but inefficient code. 2. You can comment out a block of code without putting % at the beginning of each line. The format is %. Stuff you want MATLAB to ignore. %. The delimiters % and % must appear on lines by themselves, and it may not work with the comments used in functions to interact with the help system like the H1 line. 3. There is a new function when solve which will solve x equals b but with the user's choice of algorithm. This is in addition to left division x equals a \b which uses a default algorithm. 4. The ETS constant now takes an optional argument. BPS x is the same as the old BPS asterisk ABS x. 5. You can break an M file up into named cells blocks of code each of which you can run separately. This may be useful for testing/debugging code. 6. Functions now optionally end with the end keyword. This keyword is mandatory when working with nested functions. B.3 Further details. 1. You can dock and undock windows from the main window by clicking on an icon. Thus you can choose to have all figures, M files being edited, help browser, command window, etc. all appear as panes in a single window. 2. Error messages in the command window resulting from running an M file now include the clickable link to the offending line in the editor window containing the M file. 3. You can customize figure interactively labels, line styles, etc. and then automatically generate the code which reproduces the customized figure. 64. Feval is no longer needed when working with function handles, but still works for backward compatibility. For example, x equals xin, xpi will produce xinpi just like feval xpi does, but faster. 5. You can use function handles to create anonymous functions. 6. There is support for nested functions, namely, functions defined within the body of another function. This is in addition to subfunctions already available in version 6.5. 7. There is more support in arithmetic operations for numeric data types other than double, e.g. single, int 8, int 16, uint 8, uint 32, etc. Finally, please visit our webpage for other details. http://computing.mccormick.northwestern.edu/matlab/61 Appendix C. Main characteristics of MATLAB. C.1 History. Developed primarily by Cleve Moeller in the 1970s. Derived from Fortran subroutines LINPACK and EISPACK, linear and eigenvalue systems. Developed primarily as an interactive system to access LINPACK and EISPACK. Gained its popularity through word of mouth, because it was not officially distributed. Rewritten in C in the 1980s with more functionality, which include plotting routines. The MathWorks Incorporated was created 1984 to market and continue development of Matlab. According to Cleve Moeller, 3 other men played important roles in the origins of Matlab. J. H. Wilkinson, George Forsyth, and John Todd. It is also interesting to mention the authors of LINPACK, Jack Doggerone, Pete Stewart, Jim Bunch, and Cleve Moeller. Since then another package emerged, LAPACK. LAPACK stands for Linear Algebra Package. It has been designed to supersede LINPACK and EISPACK. C. Strengths. Matlab may behave as a calculator or as a programming language. Matlab combines nicely calculation and graphic plotting. Matlab is relatively easy to learn. 62 Matlab is interpreted not compiled. Errors are easy to fix. Matlab is optimized to be relatively fast when performing matrix operations. Matlab has some object-oriented elements. C.3 Weaknesses. Matlab is not a general-purpose programming language such as C, C++, or Fortran. Matlab is designed for scientific computing, and is not well suitable for other applications. Matlab is an interpreted language, slower than a compiled language such as C++. Matlab commands are specific for Matlab usage. Most of them do not have a direct equivalent with other programming language commands. C.4 Competition. One of Matlab's competitors is Mathematica, the symbolic computation program. Matlab is more convenient for numerical analysis and linear algebra. It is frequently used in engineering community. Mathematica has superior symbolic manipulation, making it popular among physicists. There are other competitors. Scilab, New Octave, RLab. 63 Bibliography. 1. The MathWorks Incorporated Matlab 7.0 R14 SP2. The MathWorks Incorporated, 2005. 2. S. J. Chapman. Matlab Programming for Engineers. Thomson, 2004. 3. C. B. Moeller. Numerical Computing with Matlab. Siam, 2004. 4. C. F. Van Loan. Introduction to Scientific Computing. Prentice Hall, 1997. 5. D. J. Hyam and Ann J. Hyam. Matlab Guide. Siam, 2nd edition, 2005. 6. K. R. Coombs, P. R. Hunt, R. L. Litzman, J. E. Osborne, and G. J. Stuck. Differential Equations with Matlab. John Wiley and Sons, 2000. 7. A. Lot. Matlab, An Introduction with Applications. John Wiley and Sons, 2004. Kate J. Cooper. The Matlab Companion for Multivariable Calculus. Academic Press, 2001. 9. J. C. Poking and D. Arnold. Code Using Matlab. Prentice Hall, 2004. 10. D. Kahamer, C. Moeller, and S. Nash. Numerical Methods and Software. Prentice Hall, 1989. 11. J. W. Gamble. Applied Numerical Linear Algebra. Siam, 1997. 12. D. Hausch. Applications of Matlab, Ordinary Differential Equations. Internal Communication, Northwestern University, pages 1 to 12, 2005. 64.